Another curve fitting procedure is incorporated when the required best fit curve has x as an exponent. Learn how to fit such a curve in numerical solutions to CE problems. When the required curve format is in y is equal to a raised to x times b, a different procedure is followed. It would be the same start to transform the equation into the linear general form y is equal to ax plus b. Instead of plugging a coordinate at this point, the exponent x can be drawn down by using the logarithm of the parameter base 10. After coming up with the modified equations, group average method is then employed. Example 1 requires a best fit curve in the form y is equal to a raised to x by b with the following data. Transform the equation into y is equal to ax plus b, and this is done by using logarithm of the equation that will turn the formula logarithm of y base 10 is equal to logarithm of a raised to x times b base 10. Distribute logarithm base 10 on the two terms, making the equation logarithm of y base 10 is equal to logarithm of a raised x base 10 plus logarithm of b base 10. Now exponent x can be drawn down, having the resulting equation as logarithm of y base 10 is equal to x logarithm of a base 10 plus logarithm of b base 10. Note that from this point, the equation can be taken as y is equal to ax plus b, where y is logarithm of y base 10, a is logarithm of a base 10, and b is considered logarithm of b base 10. The smaller groups taken after dividing the dataset into two would include a table with an additional column for capital Y, which is computed as the logarithm of y base 10. Complete the table and determine the total and the average. From those values of the averages, the first equation is identified as negative 0.57623 is equal to 0.30a plus b. The same procedure is continued on the second group of dataset. Fill up the columns of x and y from the dataset and compute for the values of capital Y, and take the total of the first and third column with their corresponding averages. The second equation is then taken as negative 0.057224 is equal to 0.80a plus b. Having two equations for the two unknowns, work with elimination to compute for a. Take equation 2 minus equation 1, giving 0.5a is equal to 0.519006. And dividing both sides by 0.5, a is then determined as 1.038012. Replace a with a value in equation 2, giving the equation 0.8 times that of a, which is 1.038012 plus b, is equal to negative 0.057224. And that value of b is taken as negative 0.887634. So the best fit curve for the dataset is f of x is equal to 1.038012 raised to x times negative 0.887634. Example 2 would have 5 points, but the procedure of dividing them in groups would still consider the first group as the one with excess. The transform equation for y is equal to a raised to x times b is the same, where y is computed as logarithm of y base 10, a is taken as logarithm of a base 10, and b is logarithm of b base 10. Starting with the first group, complete the entries, and then compute the total average for both x and capital Y. By arriving at x is equal to 1 and y is equal to 0.257929, the first equation is then 0.257929 is equal to a plus b. The second group would be comprised of only 2 points, but just the same, take the total and average of x and y, where in this case, x is equal to 3.5 and y is 0.726277. The second equation is then taken as 0.726277 is equal to 3.5a plus b. The first and second equations are determined, and by subtracting equation 1 from equation 2, 2.5a is equal to 0.468348. Thus, a is taken as 0.187339. By plugging this value into any of the equations, say equation 1 for this case, b is then computed as 0.07059. The best fit curve is then with the equation f of x is equal to 0.187339 raised to x times 0.07059.